their systems. So let's start with
Recording in progress.
the second and last unit for today. So in case there are any further questions related to the content link or related to the link to the certification journey or the learning journey, just let me know in the chat or Q&A. I will be answering them at the end of the session. So let's start. So what is SQL? SQL is basically a language that we use if we have to write a code in the SAP HANA modeling scenarios. SQL plays an important role in SAP HANA modeling and can be implemented in different SAP HANA modeling objects such as SQL expressions in calculation views, procedures, functions, or SQL-based analytical privileges. SQL is used to implement custom logic in calculation views where the standard features of graphical calculation views are not enough. Please note that SQL should not be considered as an alternative approach to graphical modeling. For example, you should not create an SQL-based object, function, or procedure to achieve a result set that a graphical calculation view can achieve, if you have advanced SQL knowledge. Calculation view provide more optimization possibilities than SQL as they generate their own SQL code at runtime based on the variety of query conditions and implement advanced pruning to generate the leanest code possible. That is why the 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 right way of like the preferred way of creating a data model in SAP HANA Cloud is a graphical calculation view. But in case we have a custom logic to be implemented that cannot be achieved using the graphical view, then we create a SQL artifact. So where we write SQL, basically mostly we write SQL in the SQL console. The SQL console, which is available in the Database Explorer, is used to write and execute ad hoc SQL statements. Database Explorer can be launched in its turn from Business Application Studio. Although the SQL console is ideal for executing ad hoc one-time instructions such as creating a temporary table or executing a test query, it is not recommended for generally generating persistent development objects such as functions, procedures, or table that will become a part of the application. For this, we recommend you to create a source file type that corresponds to the object that you wish to create. For example, if you want to create a table, you should not do using the SQL console, but you should create an artifact of the type .table HDB table, or if you want to create a function, you should create an artifact of the type .hdb function. When you deploy the source file, the corresponding runtime database object will be generated. Please note that when launching the SQL console, you need to be aware of which database connection you are using, because when you execute the SQL, the output of it will depend on which connection you are into. But regardless of the connection you choose, you can easily swap the connection by using the button connect this SQL console to a different database. There are two main types of database connections when you want to build a connection. One is the HDI container, while second is the SAP HANA database, also known as the catalog. It is important that you understand which type you are writing statements against in your SQL console, because this affects how you write the SQL code. When executing the statements against the HDI container, you do not need to specify the schema. The schema is already known to the container you are running the statements against. However, if you are executing statements against a connection that is a SAP HANA database catalog type, then you must specify the schema in your statements. So as you can see in the slide, if we are using a catalog, then we have to write the schema name with the table name. While if we are using a container, then it will access the objects that are inside the container. So we don't have to explicitly mention the schema name here. We can just directly write the table name and it will work. Apart from the console, we use SQL statements inside the calculation views also. SQL can be used to create custom expressions in the calculation view to define calculated columns, filters, and restricted columns. In addition, SQL can be used to return values in the input parameters. For example, SQL can return the top customer of the month and can pass this through an input parameter of a calculation view as a filter. This is very powerful feature because input parameters are used in many places throughout the calculation views as dynamic placeholders where you do not want to provide a fixed values for filters, ranking, user prompt, calculations, etc. As you can see in the slide, there is a long list of available functions that is available for SQL. These functions can provide significant additional options when you are trying to develop some logic where data must be manipulated. For example, SQL provides many string manipulation functions which are useful for reformatting a field. Also, there are many predefined data functions available in SQL that will help you to calculate with dates. For example, you can find any number of days between two dates using the days between function. So these are the standard set of functions which are available when you write a SQL expression. So that way you can have the desired logic implemented. How to use SQL inside the expression? I have already discussed in the last unit when we were discussing the calculated columns and restricted columns. There are different type of expressions that you can write. Then after using SQLs in the inside the calculation view, another place where we use the SQL is in the persistence layer. So let's discuss that. The persistence layers of SAP HANA refers to the physical data storage layer. In a relational database, such as SAP HANA Cloud Database, it is modeled using database tables. On top of the persistence layer, we build a virtual layer using calculation views. A modeler is not responsible for development of the persistent layer, but it is always good to be aware of the approaches necessary to create tables and how much effort is required to create or adjust tables if necessary. Because we work with tables, so it's always good to have the knowledge of how we create tables and how to load data into them. As you can see in the slides and the coming slides, we'll see how to create tables. In the first image on the left, we see a simple SQL statement for the creation of a table in SQL console. Once the statement has been executed, we have the table sales that we can browse and see the metadata. In the second image, you can see that the same table can be created using building a source file from Business Application Studio. In this case, once the folder where we want to build the file is chosen, you can create a new file with the suffix .htb table, and then in the text editor, you need to type the syntax, which is very similar to the syntax that we used in the last slide, except for the case create statement. Here we also have to add the namespace, and then we deploy, and the similar table will be created in the database artifact. So that was theory. Now let's see in a demo video how we create table using SQL, as well as we create table using the Business Application Studio, the design time. In this demo, we will see how to create a table in SQL in Business Application Studio. There are two ways to create a table. Firstly, we'll just go to the container and open the SQL console. Here, we have to write basic syntax to create a table. We will be creating a table called products here.
We have to write create column table, then the column name, all the fields, their data types, and then we have to click execute. So as we can see, a table called product is created here. If we click on this, we'll see that the table is created like this. The second way is to open Business Application Studio. Here we'll go to the data folder, right click, new file, and we'll create a file with the extension HTB table. Click OK. Here we can paste the same syntax, but we have to remove the word create. Also, as the product table is already created, we have to change this name, so we can rename it to product_1. Now let's deploy this. So the file is deployed. Again, if we go to Database Explorer and refresh this, we'll see that product_1 table is also created. If we open this, we'll find that the structure of this table is same. So this is the way we create table in Business Application Studio.
So this is how we create tables. There are two ways, but the preferred way is obviously creating a .htb table extension file and then doing the syntax. So once the table is created, the next step is to load data into the table. So now let's see how we load data into the table.
In this demo, we will see how to load data into a table. Here we have created a table called sales product using the new file creation method like this. If we open the Database Explorer and see this table and click on open data, right now this table is not having any records. For adding data to this table, we have to create another file that will add data into this table. We will give name and the extension .htb table data. Click OK. Here we will add the following syntax. Here the target table field has the table on which we have to add the data. The data type is the type of file that we are using to add the data. The file name is the name of the file that we use to add the data. Here we have given the file name products.csv. As we can see, this file is located here, and if we open this, we can see that it has a lot of data. Let's execute this file. So the file has been executed. If we go to the Database Explorer again and refresh the screen, we will see that the table has been populated with the records. Thank you.
So this is how data gets loaded in the table. So that was the use of SQL in the persistence layer. So the next topic that we're going to discuss regarding uses of SQL in HANA Cloud is the how we can use a
query a model hierarchy using SQL. A hierarchy that is defined in a calculation view can also be accessed directly by SQL statements. But before you can write a SQL query, you need to work on a certain setup. So let's go into that steps. So the first step is the hierarchy you wish to query must be defined in a dimension calculation view, which must then be consumed in the start join node of a cube calculation view. This is because only shared hierarchy can be read by SQLs. Secondly, you must allow the shared hierarchy to be exposed by SQL by setting a parameters in the property tab of the semantic node, that is the this one, and enable hierarchy for SQL access. Thirdly, in the SQL access section of the hierarchy tab in the semantic node, you should find the name that is given to the node column because you will need to refer this in the SQL statement. So here we have seen the node column. So the node column is mentioned as h underscore geo node. And once we enable the hierarchy for SQL section, then if we write a SQL statement in which we write select the node column and the measure from the hierarchy group by the node column, then we can see that the output of the hierarchy is like we populated the output of the hierarchy using the SQL code. So if we want to use the SQL code to query a model hierarchy, then these are the pre-steps. Using SQL to read hierarchies is supported for both type of hierarchies, that is the parent-child as well as the level hierarchy. So in this way, we saw various usages of SQL in the um, Business Applications Studio. Now let's see some key reasons and benefits of using with SQL script. SQL script is a database language developed by SAP that is based on standard SQL but adds additional capabilities to exploit the advanced features of SAP HANA Cloud. The SQL scripts allows you to use variables to break a large complex SQL statement into smaller, simpler statements. This makes the code much easier to understand and also helps the SQL HANA cloud performance because many of these smaller statements can run in parallel. So SQL script extend NSI92 SQL and it allows the use of SAP HANA specific features like column tables, delta buffers, fuzzy test searching, predictive analytics library, etc. It allows developers to push data intensive logic into the database and also encourages developers to maintain algorithms using set oriented paradigms instead of one record at a time paradigm. SQL script also allows looping through the result and using the if then else logic. It also allows breaking complex queries into smaller statements, implying so simplification of SQL coding and enhancing parallelism via the optimizer. So now let's see various SQL scripts data types. SQL script also adds extra data types to help address missing features from standard SQL. For example, spatial data types and text data types. These data types are listed in this slide, NSI92 and SQL script data types. So these are the standard data types of SQL and these are the SQL script specific data types. You can see that these all are already included and these are the additional data types that are supported in the SQL script. Another difference between the two languages is about the variables. The use of variables in SQL statements is not specified by NSI92 SQL. In SAP HANA Cloud, SQL script implements the concept of variables as an extension to NSI92 SQLs.
Variables can be declared, assigned, and reused within the script when we use the SQL script. So how we use variables in the SQL script? So basically there are three steps. Variable can be declared, assigned, and then used within the expression. So for declaring a variable, there are two, like this is the syntax: declare variable name, variable type, and then the default value. For example, if we just want to declare a variable of name A, we have to write declare A and the data type, which is integer. Secondly, we can declare a variable B with a default value 0. So that way it is having a default value 0, same data type. Then the variable assignment. So the we can assign a value as well as another expression to the variable. For example, we can assign default value 3 to the variable A, while for B we can assign a expression and the count of the base table will be stored in the B. Thirdly, we can use these variables in the expression. The syntax being, we have to write a colon, then the variable name, and then the logic. So basically it will be like colon B equal to colon A plus 5. So it assigns the value of A plus 5 to B. From a general standpoint, SQL code is written in a declarative way. This means that you state the intent of the action and do not specify how the data processing step should be executed in a particular order. We do this so that you allow SQL Optimizer to figure out the best execution plan based on many dynamic factors at runtime. However, sometimes we need to control the flow logic of the SQL so that steps are executed in a particular order. For example, when you need to perform a step only when certain condition is met, you need to loop a number of times. In this case, we will use imperative logic. SAP HANA provides declarative logic language as part of SQL script to provide flow control. Lack of imperative logic language is what often causes a developer to move the processing of data to the application layer. When an application runs on HANA, we should push as much data processing to the database as so that we can make the most of SAP HANA SQL script imperative logic. But for best performance, we should avoid the imperative logics. Then comes the dynamic SQL. It allows the construction of an SQL statement during the execution time of a procedure. There might be elements of the SQL code that cannot be known until runtime. For example, the name of a table or the name of a column may not be known until a session variable is filled or a lookup is performed on the current data. In that case, we use dynamic SQL. The main advantage of using dynamic SQL is that we can use variables. It allows use variables where they might not be supported in SQL script and provides more flexibility when creating SQL statements. The disadvantages is like the statements are potentially recompiled every time it is executed and may expose the database and then the entire system to vulnerability. Although supported, SAP recommends that you carefully consider whether you really need to use dynamic SQL because it might have a negative impact on the security as well as performance. So the major disadvantages of using dynamic SQL is that it limits the opportunity for optimization because we have to potentially recompile every time we run the script because it will be dynamically passing you the table name or the column name and it will obviously change the whole logic. Also, it can potentially harm your system by injecting the SQL bugs on the integrity and the security of the system. but it adds to the flexibility. That is why they give that option. So the next topic that we are going to discuss is a very important topic, and this is where mostly the SQL comes handy, which are the functions. Functions or user defined functions UDF allows developers to capture a reusable block of SQL script code that provides a result after working through some data processing logic. Often functions allows input parameters to pass key information to the processing logic so that function can be reused in different scenarios. Functions are relevant to SAP HANA Cloud Modeling because they offer a way to extend the standard capabilities provided in the graphical calculation view to reach more complex data processing possibilities. Functions are written in SQL script language using source files. After a successful deployment, a runtime object is generated from the source file. When executed, function always return in the in-memory SAP HANA Cloud database, and so performance is always optimized. SAP HANA Cloud supports two types of functions, scalar functions and table functions. Table and scalar functions are created as source files in the project folder. The source file has the extension .hdb function, both for table as well as scalar functions. Functions are always read-only and they always provide a certain output based on the input parameters. But they can be stacked and we can call other functions inside the main function to provide a modular approach. So let's take into the detail the scalar function first. One of the most common uses of a scalar function in a calculation view is to derive values for the input parameters. A simple example of a scalar function could be to return the current date. However, scalar functions can be more complex and can read tables and call other databases, including other user-defined functions. Peculiarity of a scalar function is that it returns one or more parameter, but each parameter always returns a single value. That is why it is called a scalar function. Scalar functions might have one or more input values, although these are not mandatory. For example, for returning the current date requires no input parameter. On the contrary, if you want to return the date that is X days earlier to today, then you would need an input parameter X that can be provided by the user. So if the user provides, for example, 2, so it will return a date which is 2 days earlier to the current date. So if we want to add the dynamic feature, then we have to add the input parameters, but it's not mandatory. Report depending exclusively on the reporting needs. In the slides, you can see the example of a scalar function syntax. So if you see, we write function, then we write the runtime namespace, then we double colons, then we write the function name, and then if there is any input parameter required, then we add that in brackets. Then we write returns, and here we write returns if it is a scalar function, and we write returns table if it is a table function. Then if it is a table, then we have to write the number like the column names. If it is not a table, it's a scalar function, we just have to write returns. Then language SQL script as begin. This is the standard statement. Then after begin, we have to write the logic that we need to perform using the table name. So here if you see, we have written return select A variable name into B as B from my table. So here A and B are the values that we are returning, and then end.
So this is the function logic basically. It can change depending on what you want to create. And then if we deploy this, then it is used as a function. So now how to use this function? Then we have to use this function inside a calculation view by adding a function node and then using it. So then when we execute the calculation view and do the data preview, then it will give you the resulted output. The next type of function that we are going to discuss is the table function. Table functions are used to return a tabular data set as opposed to a single value parameter. A tabular data set can consist of one or more columns and usually has multiple rows. Refer to the function wherever a data source can be defined, such as in a calculation view projection node or join node, just as you would include a table. In fact, it might help you to think them as dynamic tables that are created as runtime. As an example of a table function, consider that you may need to read through a table that contains sales order so that you can find open orders that have been recently created. The date used for determination of this required orders is based on an input parameter passed from a calculation view. The resulting open orders are passed to the calculation view as a data source. So as you can see in the slide, below the join node, we add the table function and we join this to the product table. After joining, it will give the desired logic. In the table function, we have to find all open orders since the last 30 days. So here we give that date as a parameter to determine the cutoff date, and then we do the logics on the order table. So this way we work on that. Since SAP HANA Cloud 2.0 SPS01, a new calculation node is available, which is called the table function. This node type is conceived for handling different types of mapping of the input parameters in the table function. It is possible to achieve the same outcome using other nodes, but this new nodes makes things easier, more intuitive to define the parameter mapping. Let's see the main features of it. There are three types of input parameter mapping available in the table function node. As you can see here, please note that this topic is very important from the certification point of view. First is the data source column. In this case, you need to add a data source to the table function node and then map one of its column to one or more table function input parameters. The second one is an input parameter. In this case, you choose an input parameter from the calculation view and map it to one or more table functions input parameters. In the third case, it's a constant. In case you have to define manually a fixed values and map it to one or more table function input parameters, you can go and add a constant value. And then that constant value will be used inside your input parameter as a parameter value. For a detailed explanation on how to consume a table function using a table function node, you can refer to a demo available that is in the learning material. So if you see in the table function node, for example, if we have a table function that has three input parameters, the name, and then first name and the last name and the sex. So there are three options. Like here you see, either you can map it to a data source column from the table, and then any value that is present in the data source table will be directly passed as parameter. Secondly, you can use an input parameter to create that value, and whatever user will be passing, that value will be passed inside the first name. And thirdly, you can hard code it. Hard coding means adding a constant value, which is mentioned as C here, a blue C. So basically here, if we write female, then the value female will be
not dynamic. It will be hard coded as a value and it will be dynamically passed to the input parameter of the table function. So this way we handle the input parameters inside the table which are used inside the table function using these three ways. So that was theory. Now let's see a demo video in which we create an input a table function. So here how like in the business application studio, every artifact that we usually create is using a extension. So like for table we create HDB table. So for functions we create HDB functions. So let's see and we'll see how to basically create that artifact and then how to use it.
In this demo, we will see how to create a table function in SAP Business Application Studio and how to use the same in a HANA calculation view. To create a table function, we can go to View, Find command, create SAP HANA database artifact, then choose the artifact type table function. This has the extension HDB function. Then specify the artifact name and click Create. So the table function initial screen looks like this. This is the table function name. Here we can specify the input parameters if needed. In our example, this table function is having one input parameter, so we'll just add that. So the name of the input parameter is IP underscore postal code. In the returns, we have to specify what this table function will return. So in our example, this will return a table. So we'll add the appropriate syntax. So this table function returns a table with the following fields. Between the begin and end statement, we can write our logic. So here the logic will be evolving the following sentences. So our table function reads the following fields from the table addresses where the postal code is what we use in the input parameter, and we have added a function fuzzy so that it will, even if we don't add the exact same postal code, it will do the fuzzy search. So this is the basic syntax of our table function. We will just activate it and deploy. So our table function is created. In order to use the table function in a calculation view, we will go to the new file option and we'll create a new calculation view. We'll give the extension. We will create this one of the type dimension. To add a table function, we need to go to the create table function node and add it in the view. Here we have to add on the second button from the top, add table function. As we can see, the data source type here is automatically filtered for table functions. Let's write the table function name. So this is our table function and click finish. Click expand. We can see that the 7 columns that we created as the output of the table function are present here. In the input mapping, we can see that the requested input parameter is present here. To map it, we need to add a input parameter here. So let's create an input parameter called postal code. Let's give the same data type and length as the input parameter. We can also provide some default values. Like here I can add. Now when we go to input mapping, we can map this input parameter to a. Now let's add this table function to the projection. Map all the output columns. In the semantics, just see and deploy this view. So the view is activated. Let's see the data output. So we can see that the input parameter that we created for the view is here. It is as it is having some default value. Let's just click execute. If we see the raw data, we can see that fuzzy search is applied on the postal code, and we see all the 5 rows that are present in the table that is present for the specified postal code range. Thank you. So this is how we create a table function. And table functions are most widely used objects when we think about SQL and the scripted views, obviously. So this was all about the second unit and the last unit for today. So now it's time for the second poll, the second knowledge quiz. So I will be opening the poll now. It will have relevant questions related to the SQL unit, and I would like all of you to be participative. And after that, we will be discussing the right answers.